So in this section, in this unit, we're going to talk about data gathering. So the first thing is surveys are often conducted to gather data about a population. So a population is the entire group of people or objects that you want information about. So this first term is population. I don't know what's going on with that, but then the next term here is a census is a survey of an entire population. So lots of times it's too difficult, time consuming, or expensive to do a census. And I know you guys have all heard of a census before. So then the third one is a sample, which is a part of the population. So that's when we actually survey just a part of the population because it's too difficult to conduct a census. So there are different types of samples. The best type of sample is what we call a random sample. In this type of sample, every member of the population has an equal chance of being selected, okay? So random samples are usually the most representative of the entire population. Here's our example. A wildlife researcher is studying the effects of certain pollutants on different types of fish in a lake. Because it's difficult and probably impossible to catch every fish in the lake, the researcher decides to use a random sample. She catches 5 groups of 10 fish each from random spots in the lake and examines them and returns them to the lake. So the table shows the number of perch and walleye from each group. So our first question here is, what is the population of interest to the researcher? So what is the researcher interested in? The fish in the lake, right? Okay, then what is the sample in the researcher's study? So the sample has to do with the number of fish that she actually caught. So that would be 50, right? Because 5 times 10 is 50. So 50 fish that were caught. Then it says use the table to estimate the ratio of perch to walleye in the lake. Okay, so how many perch do we have? That's 11 plus 3, that's 14, plus 6, that's 20, okay? And then 9 plus 12 plus 9, that's 30, okay? So then it says use the table to estimate the ratio. They're really important right there. Word of perch to walleye in the lake. Now here, this is also important. The order that these words are in, because that's what tells us which comes first and which goes on top. So we're talking about perch to ratio, or perch to walleye. We can also write this as perch over walleye. Okay, so then that's what we're going to do, is we're going to take the number of perch, which was 20, over the number of walleye. What's the GCF of both 20 and 30, y'all? 10, right? So this would reduce to be 2/3, right? So that's one way to express the ratio. Another way to express the ratio is with a colon. And then the third way to express the ratio is the way we express it in our words, which is 2 to 3, okay? Now I'd like you to try this one. Come back to me when you're done. Okay, so a researcher is gathering information on the gender of prairie dogs at a wildlife preserve. The researcher samples the population by catching 10 animals at a time, recording their genders, and releasing them. The table shows the number of males and females from each sample. So what is the population of interest to the researcher? Obviously the prairie dogs, right? And then when it asks what is the sample in the researcher study, so that's the total number of prairie dogs that she determined the sex of, right? So that's going to be 4 samples at 10 each, so that's 40, right? So it's going to be 40 prairie dogs that were caught. Okay, then using the table, estimate the ratios of males to females in the population. So once again, we're going to count our males. That's 12 plus 12, that's 24. And then 8 plus 8, that's 16. So here again, we're going to do males over females. And we're doing that, again, it asks us for a ratio, and it had males to females, right? So the males go on top, the females go on bottom. So we're going to this time do 24 over 16. What's the GCF of both 24 and 16? Yes, 8. So this is going to be 3 over 2. Again, if we write it as with a colon, it's going to be 3 to 2. And if we write it in words, 3 to 2. So this could, all three of those are the correct answer, okay? So this next part says a non-random sample can result in a biased sample. So a biased sample may not be representative of the population. So certain parts of the population could be overrepresented or underrepresented. Obviously, that's bad. So bias in a sample is not always obvious at first glance. So we're going to actually go through some examples now and determine whether these are biased or not. So the first example here is, and it says, decide whether the sampling method could result in a biased sample. So a survey is conducted by calling 100 people randomly, chosen from the phone book, and asking how long each person has lived in the current residence. So what do you guys think? You think this is biased or unbiased? I would say biased. Why? Because they pulled them from a phone book. When was the last time y'all saw a phone book? It's been a minute, right? So obviously if people's addresses are in there, their phone numbers are in there, and you call them and they ask them how long they've lived there, they're probably going to live there longer, right? Okay, so this I would say is biased. Okay. B, a survey of students at school is conducted by contacting every 10th student from the complete roster and asking whether he or she plans to go to college. So what do you think about this one? I would say not likely biased, right? Because why? They did every 10th person from the whole roster. Okay. Third one here, which is letter C, a survey of the city's residents is conducted by asking 20 randomly selected people at a grocery store whether the city should impose a beverage tax. So what do you think about this one? I would say it's biased because the only people you asked were the people that were at the store where you were at. And so I don't think that's enough people, okay? All right, this you try says, decide whether the sample description would be representative of the population. So again, you're going to tell me yes or no, and then why. So go ahead and pause this, do each of these, and then come back to me when you're done. So it says, the owner of a health club wants to determine the percent of adults in his area who exercise for at least 20 minutes 3 times a week. He asks the first 25 adults he sees at a mall on the weekday around 10 a.m. So is that going to be representative of the population? I would say no. Why not? Because who's at the mall on a weekday at 10 a.m.? That's going to be a very small group of people. All right, B. A restaurant owner wants to know how often families in his area go out for dinner. He surveys 25 families who eat at his restaurant on a Tuesday night. Again, do you think this is representative of the whole population? Again, I would say no. Why? Because he surveyed the people that were eating at his restaurant. What about all those people that aren't? Letter C. A car dealer wants to know what percentage of the population in his area is planning to buy a car in the next year. The dealer surveys the next 15 people who come to the car lot. Again, I would say no. Why? Because the only people he surveyed were the people that were actually looking at cars. There's a pretty strong likelihood those people are planning on buying a car, right? Okay. So, our next thing is we're going to talk now about statistics and parameters. So a statistic is a number that describes a sample. We're looking at that S and S, statistic sample, okay? And a parameter is a number that describes a population. So the way I keep these straight is statistic sample, parameter, population. So you can use a statistic from a survey to estimate a parameter. So we can use surveys to make predictions about a population. So that's what we're going to do next. And you guys have probably done this before. So, example, in a survey of 50 students at a high school, 32 students said they plan to attend the homecoming dance. The school has 720 students. So the first thing we want to do is figure out what is the statistic. So that's going to be the number of students that are going to the dance over the number of students that were surveyed, right? Then what is the parameter? So that's really the number of students at the school, right? So the number of students at school, which is what? 720. So now hopefully you remember, if we want to predict the number of students who plan to attend the homecoming dance, what we're going to do is the students that want to go to the dance versus all students, right? Isn't that what we had up there? So that's going to be 32 over 50, and we're going to set that equal to, we're looking for those who plan to attend the homecoming dance, right? So that's going to be our variable. You can put whatever variable you want there. And then how many students are there at the school? The 720. So let's see if you guys remember how to do this. So aren't we going to cross multiply? So we're going to say 50x is equal to 32 times 720, right? So that's going to be 50x equals 23,040. And then we're going to divide both sides by 50, right? So x is going to be equal to 461 students going to the dance. So this is a prediction. Okay, why would we need to know this? Yep, food. You might need to know it for the size of the venue. You might need to know it for the number of chaperones. Okay, so we got one more here. Let's see if you guys can do this one. Go ahead and pause this, do it, and then come back to me. All right, here's our last question. In a random sample of phone calls to a police station, 11 of the 25 calls were for emergencies. Suppose the police station received 175 calls in one day. Predict the number that would be for emergencies. So which of these is the statistic? So that's our 11 over 25, right? So that's emergency calls over calls, right? Which of these numbers is the parameter? That would be the calls in one day, which was how many? Yep, 175, okay? So now we're going to do emergency calls over calls, right? So that's going to be 11 over 25, and then it's asking us how many calls were for emergencies, right? So there's our x, and that's going to be over 175. So once again, we're going to cross multiply, right? So that's going to be 25x is equal to 11 times 175. So that's 25x is equal to 1975, or 1925, sorry. Going to divide both sides by 25. So how many emergency calls did we have? Or are we expecting, I should say? 77, right? Okay, so here's the deal. Why would we need to know that? Because perhaps it has to do with the number of employees you need. Can one employee handle 77 calls? Probably not. So these numbers that we're solving for here are very important because they're going to help us make wise decisions.